And to make it a little more interesting this time, the second derivative is given. So we'll need to find the antiderivative, and that's going to be the first derivative. And then we need to find the antiderivative of that to get the original function f. So for sine, the antiderivative is negative cosine of x. Like I say, you can always check by taking the derivative of this, and the derivative of cosine is negative sine, so together with that negative becomes positive sine. And then the antiderivative of cosine is sine of x. And then there would be a constant, call it plus c. So this information is going to help us solve for c. It says substitute in a 0 for x, so cosine of 0 is equal to 1. Sine of 0 is 0. And then the result would be a 1. So it turns out that c is equal to a 2. So we've got the first derivative is equal to negative cosine of x plus sine of x plus a 2. And there we're already halfway done. Now find the antiderivative again, and that's going to get rid of this last prime right here. So let's see. The antiderivative of cosine is sine, and this negative sign just stays there. And the antiderivative for sine is negative cosine, and the antiderivative of a 2 is a 2x. And then plus some constant. Since I already used the c, I'm going to use k this time for constant. And this will help us solve for k. So on this side would go a 2. Sine of 0 is 0. Cosine of 0 is 1. Substitute x equals 0 right there. And it looks like k is equal to 3. So finally, we have our original function is negative sine, negative cosine of x, a 2x, and then k is a 3.